Alrighty, you saw the law of sines last time? Now it's the law of cosines. And the law and the sines and the law of cosines kind of go together. It's kind of like when we had right triangles, that's an RT for right triangles, then we had SOHCAHTOA, and we had Pythag theorem, right? And then last time we started looking at non-right triangles, not right, if you will. And I said if you have a not right triangle, then you can't use SOHCAHTOA, you can't use Pythag, not on a not right triangle. But you can use the law of sines, which is something that we saw last time. And then it turns out there's another thing you can use called the law of cosines, and it also turns out the law of cosines is pretty closely related to the Pythagorean theorem, actually. So I'll show that in action right here. So here we have a nice right triangle, which means that Pythag works just fine. Pythag. And so remember how you can solve for the hypotenuse there. This is the hypotenuse. And you say c squared is equal to, remember this how this goes, a squared plus b squared. So these are the legs over here on this side of the equation. This is the hypotenuse on this side of the equation. So c squared equals a squared plus b squared. That only works if you have a right triangle. Now if you have any triangle, if you have this works for right triangles as well, but you'd only use it if you didn't have a right triangle. But anyway, the extended Pythag, the law of cosines, I'll call it the LOC, goes like this. So instead of having this 90, we've got this different angle. We have this angle C here. So the law of cosines says, well, you know, you can still write this part, c squared plus equals a squared plus b squared, right? Which at the moment, I've just written exactly the same thing as the Pythag theorem. So you know it's not quite right. There's a little correction term here, minus 2ab cosine, hence the name of the rule of that angle C. So this is the new thing. You kind of tack that on to the end of the old Pythag theorem, and you got yourself a law of cosines. And what's nice about the law of cosines is you can use it no matter whether it's a right triangle or not. So the angle that you were kind of hoping would be a right angle so that you could, use Pythag, well, if it's not a right angle, that's fine. You can sort of use modified Pythag like this. So let me put this in a big box because this is huge. And you want to kind of stare at that for a little bit here and try to, get the idea. What's it saying? What's it saying? It's saying if you've got an angle across from a side like this, then you can use a Pythag, sort of, on this C. You can say c squared equals, and then you do the usual a squared plus b squared, but you got to remember this correction term, minus 2 times a times b times the cosine of the actual angle. By the way, P.S. Do you ever wonder what the cosine of 90 degrees is? The cosine of 90 degrees is 0. So notice that if you have a right triangle, that goes away. So basically this is always the formula that we're using. It's just that when we have a right triangle over here, cosine of 90 is 0, and so the formula reduces to this one. I think that's kind of slick. But anyway, what we should do now is we should get used to using this darn thing. Okay, here's another nice triangle for us. So it says here, major case. Most of the time we need the law of cosines when we have this situation. SAS means we have a side angle side. And by that we mean all in a row. I got a side, I got an angle, I got a side. All in a row like that, right? Side angle side. This is a side, this is an angle, this is a side. And if you have side angle side and you're trying to figure out, well, what's the other side? This is what law of cosines does best. So what you would do. Well, what I like to do is I like to write the law of cosines first. So once you write this a few times, it'll become naturally memorized. Keep it handy until you do have it memorized. But that's the law of cosines. And the main thing about the law of cosines is that you've got to You're solving for a side that's across from an angle that you know. So if I'm solving for this side, it's across from an angle that I know. This is perfect. So think of this as sort of like, instead of x, I'm going to call it c, and this is like my angle c. See what I mean? So there's a side and there's an angle across from that side. Just call them c. That's actually what I always do. Like if they label a triangle and they have A's and B's and C's and D's and thetas and gammas and phis and whatever the heck else, I just say, yeah, that's nice. I'm going to call it a C, and I'm going to call, hey you, I'm going to call it a C, and I'm going to call it an angle C, capital C. And then I can use my formula without having to monkey around looking for a different version of the formula. So here we go. So that's my C, that's my angle C. Again, they're across from each other. The A and the B, it doesn't really matter which is which. Just call one A, call one B. And then here we go. C squared equals. Take my A, which is 97.3, and square it. Take my B, which is 86.5, and square it. Minus 2 times my A, which is 97.3, times my B, which is 86.5. And then times the cosine of that angle there, the angle across from side C again, which is 18.0 degrees. Now, the big challenge is going to be getting this on your calculator without making any mistakes. And I'm finding with my calculator it's getting old, so the buttons are getting sticky. So you might want to keep an eye on what you're actually entering. So I'm going to go like this, 97.3, and then there's a nice square button, right? So I entered the 97.3, I hit the square button. Plus, now I enter the 86.5, and I hit the square button. Yep. Now I hit the minus, and I hit 2. And if you want, you can actually enter parentheses. I don't think I have to. I'm just going to say times 97.3 times 86.5 times, and then I'm going to have to hit times again. Cosine of, stick the 18 inside the cosine, close my parentheses. I hit my old equals button, and this is what I got. C squared is equal to roughly 940.5008. I rounded that off a little bit. What you want to do in practice is, you don't necessarily want to write this down. What you want to do is leave it on your calculator so that now C is going to be the square root of, you hit the answer key, right? Because the answer key gives you all the decimals you need. And by the way, what your calculator shows you for decimals, sometimes that's not the whole thing. Sometimes it has more in the background. But anyway, C is the square root of that. So I hit the square root of answer, and I'm getting 30 point, let's see, they gave me 1 decimal place. I'm going to go with 2 decimal places. I like to go a little bit further than they did. 30.67. And that seems realistic, doesn't it? If that's 97, that's 86. That's got to be something a lot shrimpier. So yeah, 30-ish or so. I can dig it, buddy. I can dig it. Okay, so you might want to, at this point, just kind of pause, maybe rewind, and just say, can I do that? Can I set up that myself? Repetition's a little good for you. Or if you want, you can come down and we'll look at this one. I know. Why don't you just pause and do that one yourself? There we go. You're back already, are you? Okay. Well, again, we're solving for a side, and fortunately, we have the angle across from it. And what makes me think of law of cosines is that I happen to know a side angle side, side angle side, right in a row, boom, boom, boom. Now, before I apply the law of cosines, dig this. Law of sines ain't helping. The law of sines ain't helping here. You might say, well, wait a minute, we used to do the law of sines. We did it last time. It was so much fun. Let's do it again. Sine of 72.4 over x equals, right? Remember how you do the law of sines? You take the angle in the opposite side. You say the sine of this over this. Start setting up a proportion. Sine of 72.4 over x equals. And then it's like, well, you get your choice of sides. Problem is, you don't know either one of these angles. There's no way to get them. If all you have is the law of sines, there's no way to get them. You're stymied. You're bumming. And so that's why we need the law of cosines. That's why we need the law of cosines. So again, Law of sines ain't helping, but it's sine equals side, so bring in LOC for law of cosines. Now, I always write down the same formula every single time. C squared equals A squared plus B squared. Whoops, not equals. Not equals. C squared equals A squared plus B squared minus 2AB cosine of angle C. That is the law of cosines. Then what you do is you come over here to this triangle that we're playing with, and you say, well, what's the side I'm trying to solve for? I'm trying to solve for this side. Let me just call that a C, please. And then this is the angle across from that, so that would be capital C. Okay, cool. And now I can shove stuff in here. So one of these is an A, doesn't matter which one. The other one's a B, doesn't matter which one. So C squared equals, take my A, which is 77.3, and square it. Take my B, which is 92.0, and square it. Minus 2 times my A, 77.3, times my B, 92.0, times the cosine of that angle C, 72.4 degrees. There, look at that. I even fit it in. Okay, so C squared equals, button pushing time. Make sure you get exactly the same result as me, exactly. 77.3 squared plus 92 squared minus 2 times 77.3. I'm making sure my calculator is obeying me. Yes. Times 92. Yep. Times cosine. Make sure I get the right angle in there. 72.4. Yep. It's all good. So my calculator is saying, well, if I write it all down, it's saying 10138.62257. Again, you don't usually have to write that down. It's staring at you right there on your calculator, so you just do the old square root of answer key. You see the answer key? It's right next to your equals key. So I go square root, I hit the answer, I hit the equals, bada boom, bada bing, 100 point. And again, since they gave us 1 decimal place, I'm going to give them 1 extra, just for good measure, 100.69. Side angle side, it's law of cosines to the rescue. So this is an important point. If you ever are working on a problem and you can't seem to get anywhere, that's usually a good hint that law of sines maybe won't get you anywhere. Think about law of cosines. If you have side angle side, that is the quintessential problem. Law of cosines was practically invented for that. Go away. Okay. All right. So actually, I think, boy, we're halfway through the problems already. So, okay, so 3 down, 3 to go. Of course, these get a little bit more fancy. So, what's this talking about? It's kind of like a word problem, but I helped you out a little bit by drawing the diagram there. We got a 60-foot pole. That would be that. It's placed on a hill. That would be that. Which is at 27 degrees to the horizontal. So that's what this is. So the hill is inclined 27 degrees to the horizontal. Cool. There's a guy wire, that thing. And by the way, we want to know how long it is. There's a guy wire attached to the top of the pole here, and then staked into the ground here at a distance of 50 feet down the hill from the pole. Okay, so that's what all these numbers are talking about. Now, find the length of the guy wire. So we need to find that L somehow. Somehow we got to find that L. So you first start looking at this here triangle and you say, well, this is a nice triangle. It looks like I know this side and this side. I can't use Pythag though because it's not a right triangle, but I would like to get this other side. And then maybe you remember a theme called side angle side, right? You have the two sides. Oh, wouldn't it be nice if we had that angle? If we had that angle, let's even write this down. With, man, oh man, I need a sharper Apple Pencil. With this angle, we could do law of cosines. Whoa, wouldn't that be slick? So how are we going to get the angle is the question. Because again, we would have side angle side. We'd be golden. Well, let's see. I'm going to get all this out of the way now. Our goal is to get that angle. Get this stuff out of the way too. Our goal is to get, again, to get this angle here. How can we get at this angle here? Well, I'm going to show you a little trick, which is a slick trick. And we did see it several lectures ago. We saw it a long time ago when I gave you a couple theorems from geometry. Remember we were playing around with parallel lines and stuff? A lot of times what you do in a problem like this is you just let yourself draw a parallel line. So I'm just going to kind of draw a light parallel line right here. If you're old, like me, you'd think in terms of sliding your t-square up and down the board. But I guess we don't have to do that. So I'm just drawing, this is supposed to be parallel. This is also horizontal. This is horizontal down here. These two lines are parallel. Now if these two lines are parallel, meaning this one and this one, if these two lines are parallel, then do you remember this thing? It's called alternate interior angles. Remember that idea? Alternate interior angles. So if you have something like this, this angle has to be the same as this angle. They're both on the inside of the parallel lines, interior, they're on opposite sides of the crossing line. Alternate interior angles must be the same. So if that's 27 degrees, then guess what? That must be 27 degrees. So now, do you see what this angle must be? Well, because I drew this horizontal, and because I presume the pole is straight up, we got a 90 in there, so 90 plus 27. This purple angle here is 90 plus 27, which is 117 degrees. And now we're ready for the law of cosines. Woohoo city, woohoo. C squared equals a squared plus b squared minus 2ab cosine c. You starting to get that memorized yet? Again, you can keep it handy. But it's kind of like a Pythag that's supposed to say plus c squared, a squared plus b squared minus 2ab cosine c. And the important thing is that the side you're solving for, you have to know the angle that's across from it. So this is the side I'm solving for. I needed to know the angle that's across from it. We're golden, right? We are golden. So let's start plugging in. Maybe I'll use a different color to plug in. So c squared equals, and it doesn't matter which one of these you call a or b. It really doesn't matter because, I mean, look, you're just going to add them anyway. 60 squared plus b is 50 squared minus 2 times a times b, 60 times 50, times the cosine of that angle, which is 117 degrees. Start pushing buttons. 60 squared plus 50 squared. Oh, see? I told you this calculator's flaky sometimes. 60 squared plus 50 squared minus 2 times 60 times 50 times cosine 117 equals. And so c squared is 8823.9429998, whatever. So I take the square root of that thing, square root of answer, and I'm getting 93 point, and since they have whole numbers, I'll give them a decimal place. 93.9 roughly. And these would be feet, I assume. 93.9 is the length of that diagonal, that guy wire. So law of cosines, it's a wonderful, wonderful thing. Side angle side is the main time you're ever going to use it. Let's see. What do we got here? We got Biff flying around. Well, I didn't draw you the picture, which means we're going to have to get used to trying to interpret these. What's this saying? What is this saying? It says we got Biff. Biff is flying. Biff is flying 300 miles at a direction north 34 west. Well, don't write this down. I'm being scrappy here. North 34 west. What does that mean? That's north, that's west. What's north 34 west? North 34 west means start by looking north and then rotate your face 34 degrees towards the west. So it's north, rotate 34 towards the west. And he's going that way, okay? He's going that way. That's what that means. All of a sudden, he changes his bearing to north 12 east. North 12 east would be, well, let me just draw another one. North 12 east would look like this. There's north. Rotate your head 12 degrees towards the east. It would be this direction. So he's kind of going up and going up. Okay. So now that I've messed up my paper here, let's draw it pretty neatly. So it's kind of like, I'm going to have him start down here. So he starts down here. Start. He flies 300 and then 200. Okay, 300 miles. So I want to make a line that's about 300 miles long. I'll use a scale, of course, but I want it to go north 34 west. So I'm going to think in terms of this is north, rotate towards the west 34 degrees. So this here is 34 degrees. And we're going to say that he went 300 miles, so let's just darken this line because he's going that way. I'll put an arrow there. And this is 300 miles. So that's the first leg of his trip. Now I think I'll change colors for the second leg of his trip. The second leg of his trip, he changes his bearing. North 12 east. Well, what you're going to want to do is you're going to want to put like a brand new XY axis over here, right? It's almost like sliding that T-square again. Make a new horizontal, make a new vertical, because he's here. So we have to figure out, okay, where's north 12 degrees east from here? It would be, remember you have to go, you have to rotate, this has to be 12 degrees. So you would face north, you would rotate towards the east, which is to the right, 12 degrees. Try to make that look like a degree symbol. That's a little better. And he's only going 200 miles. So I'm trying to make this line look like it's maybe not quite as long as this one. That's not long enough. Maybe something like this. I don't know. Now, if you want to do this really nice, get yourself a CAD program or get yourself a ruler and protractor. But let's just say he ends up there. And then this length is 200. Cool. So he started here and he ends here. And now what's the question? The question is, how far is he from where he started? Well, he started over here and he ended over here. So if you join these kind of carefully, what we're trying to figure out is the length of that little green line there. Now, this is the lesson on law of cosines, right? So if nothing else, that's going to be the first thing that makes you ask, hey, can I get side angle side here? I mean, dig it. I got a side, I got a side. What I would need is to get the angle in between. And notice I would be wanting the side opposite. It's all golden. But I have to get this angle in here. How am I going to get this angle in here? Well, this is where you have to start scratching your head and doing some detective work. So always use your, orient yourself to north, south, east, west. I'm looking right here at this part. Can you tell what that must be? That part has to be, well, see, this is a right angle here. So if that's 12, that must be 90 degrees take away 12, which would be 78 degrees. From there to there is 78 degrees. I'm going to change my color again. Now that's not the full angle here, it's just part of it, but the other part of it is right here. And can we figure out that angle? Well, see this 34 degrees, be careful about this. This 34 degrees, it doesn't go to the green line, right? It goes to the due north line. This is the angle between this arrow and due north. That's what the 34 is. Now if you follow the due north up here to the due west, well there you're talking about a right triangle. Let me make this look a little bit neater. So this is a right triangle. If this is 34, you can figure out what this is, right? Because that's 90. So the two acute angles must add to 90. So 34 plus what equals 90 is the question. And 34 plus 90, 34 plus what is 90? It would be what, 56, I want to say? Yeah, 56. And so now we know, okay, I need another color. We're going to get brown. I feel like a UPS guy all of a sudden. So this angle here, I'm going to call it angle C. I'll call this my side C. So instead of X, I'll call it C, and that's going to be my angle C. And it's basically 78 plus 56, which is 134 degrees, right? 14, 7, 12, 13, yeah. 134 degrees. So we succeeded. We got the angle that we wanted. We have the angle, we have the side across from the angle, and we know the two other sides. We know side, angle, side, right in a row, side, angle, side. We're ready to fly. So call one of these an A, and call one of these a B. Doesn't really matter which one. I guess I'll call that the A, I'll call that the B. Write down your law of cosines. C squared equals A squared plus B squared minus 2AB times the cosine of angle C. So C squared equals A is 200 squared plus B is 300 squared minus 2 times A is 200, B is 300, times the cosine of that angle that we just figured out, 134 degrees. C squared equals, and let's see where we go here. 200 squared plus 300 squared minus 2 times 200 times 300 times cosine 134. Boom. This is telling me something like 213, 359.0045. Yep. Take the square root's what you really got to do. Square root of the answer is, so this distance is just about 461.9 miles. Quick reality check, that's 300, that's 200. It's got to be something a little less than 500, right? Because if we went 300 and then 200 in a straight line, it would be 500, but we didn't, we bent. So it's got to be something a little less than 500, so 462 sounds about right. I like it. So, part of the point I've been making this whole lecture is that law of cosines works really great for side angle side situations. As I pointed out before, let me scroll back up. As I pointed out before, like here, sometimes you know that you need to try the law of cosines because you get stuck. There's like nothing else you can do. You can try the law of sines. That's how I solve these triangles. If it's not a right triangle, I always say, okay, law of sines, law of sines, law of sines, law of sines, until I get stuck. And if I get stuck, I say, I must have to do a law of cosines. Look for the side angle side, okay? So even on your homework, really you should ask yourself first, can I do law of sines? Because if I can do law of sines, I'm going to do that because for one thing, it's an easier formula. For one thing. Okay. Now we're going to end. Oh, I'm in a purplish mood, I guess. We're going to end with the other time that you use the law of cosines. There's two situations. Side angle side was one of them, or side, side, side. If you happen to know nothing but the sides and you need an angle, then you can use the law of cosines. Again, well, first of all, you're not using any SOHCAHTOA because it's not a right triangle, so don't even think of that. And law of sines doesn't get you anywhere. I'm going to say stalls. Because, you try to make your proportions, you say, well, the sine of angle A over 7, cool, equals the sine of angle B over 10. Well, here's the problem. You get two things you don't know. How are you supposed to solve it? You try the other angle, but then there's something else you don't know as well. So the law of sines is not working. So you need something else for sure. Law of cosines to the rescue. And the first thing you do is you write it down. C squared equals A squared plus B squared minus 2AB cosine of angle C. And then the next thing you do is you pick a side and an angle that are across from each other. Because that's what the formula applies to, a side and an angle that are across from each other. So if you want to solve for angle C, this is going to be side C, right? So, by the way, that's standard naming notation. I don't know if I ever mentioned that in this course, but usually you call one angle A and it doesn't matter which one. You call another angle B, but the side across from that is little b. You call another angle C, and then the side across from that is little c. So A across from A, B across from B, C across from C. That's actually standard kind of geometry stuff. But be that as it may, we're going to call that C, and we're going to be able to put it into our formula. The A and the B, well, actually, you know what? I might as well follow that convention. If this is B, we'll call this little b, and if this is A, we call this little a, just again following a naming convention. Come on, you. Now, here's the nice thing. We know almost everything to plug into this formula. Notice this time I know what the C is. I can plug that in over here. The A is a 7, the B is a 10, minus 2 times A times B. And so the only part of this formula that we don't know is over here. But if we know everything else, then in principle, we can solve this formula. We can solve it for C. So what do? You start going like this. That's a 25, that's a 49, that's a 100. 2 times 7 is 14. 14 times 10 is 140. Cosine of angle C. So you do the old subtract 49 on both sides, and then you do the old subtract 100 on both sides, right? And then what have we got now? Now we've got, let's see, negative something, right? Is this negative 124? 49 minus 25 is 24. Yep. Okay, negative 124 on this side. And over here you've got negative 140 times the cosine of angle C. Okay, so how are we supposed to get at angle C here? Well, first get the cosine part by itself, which means you divide both sides by the negative 140. So notice the negatives are going to cancel and the 140s are going to cancel. Over here, the negatives cancel. 124 divided by 140 is roughly 0.885714, roughly. I'm just writing this down so we know where we are, right? That equals the cosine of angle C. I've got a longer decimal than that sitting on my calculator screen right now. But if you want to get C out of the cosine, you have to do one of these shift cosine things, right? So let me actually get that out of here. Let me just do it this way. Shift cosine of that number. The official math notation is cosine with a -1. But again, not an exponent. It's a notation, not an exponent. It means inverse cosine. It means shift cosine is what it means. So anyway, if you do that, shift cosine of that number, so I've got that number staring at me on my calculator still, so I go shift cosine answer key equals, and it's giving me 27 point, and with angles I often like to go to 2 decimal places, 27.66 degrees. Let's go back there and label it. That was angle C, huh? 27.66, that's right here. Pretty cool. Let's say you wanted to get another angle, right? Would you have to use the law of cosines again? Nope. 2 pieces of good news. One item. You never need to use law of cosines twice on the same on the same triangle. In other words, now that I've got an angle here, I can start using law of sines. If I want to get another angle, like I want to get angle B, say, well, sine of B over this is sine of C over this. So I would just say, well, the sine of angle B over 10 is equal to the sine of 27.66 degrees over, whoops, that's not a C, that's a 5. We know what that is, it's a 5. So good old proportions, right? Much easier than this law of cosines formula. So that's one piece of good news. The other piece of good news, remember there was something tricky about the law of sines, that sometimes the calculator gave you the wrong answer, that Biff's two-answer theorem. You never have to worry about that with law of cosines. Never have to worry about Biff's two-answer theorem. When using law of cosines. Come on, what is this? When using law of cosines. So that's just kind of slick. So if you're using the law of sines, be paranoid. But if you're using the law of cosines, don't worry about it. You're not gonna have to worry. You don't have to worry about it. I've never seen it happen. I don't think it's possible. Okay. I think I've just done the law of cosines. So again, there's this one case, side, side, side. So if you have nothing but sides, you can use it to find an angle. Remember, again, you only have to use it once, because after that you can use law of sines. The main workhorse, whatever you want to call this, the main situation you will apply law of cosines to is a side angle side situation. You have a side angle, and you have two sides and the angle in between, side angle side, right in a row. Always try the law of sines first when you're solving any problem, even on this homework. Always try the law of sines first, and if you're getting stuck, you know you have to do the law of cosines, and usually you're looking for side angle side. That is the law of cosines. Groovy. I think that ends our trig section.